Welcome everybody to the second problem set in the Bachelor Taxation course. In this week's problem set, we will deal with the empirical tools of public finance, where we will look at typical tools which are used in the empirical analysis of questions which are important in public finance and in particular in taxation. So, question number one. A researcher conducted a cross-sectional analysis of children and found that the average test performance of children with divorced parents was lower than the average test performance of children of intact families. This researcher then concluded that divorce is bad for children's test outcomes. What is wrong with this analysis? So this is a typical question that you would or problem that you would encounter when you're doing empirical work. In that, there is the problem with reverse causality here. So one kind of this is one of the explanation. So what is basically done here by the researcher is that he is kind of using correlation to make statements about causality. Okay, so let's dig into the question. So what is one issue? So this is question number one. So there could be an issue of reverse causality. So one issue, reverse causality. So what does reverse causality mean? So in the exercise description, we had the case that the researcher looked at the test performance of children of divorced parents and found that they were lower compared to intact families. And then he inferred that divorce is bad for children's test outcomes. But it might also be the other way around. It might also be that the parents of children who actually performed poorly in tests feel stressed, and this is the cause of higher divorce rates. Yes, so it's the other way around. So it could be that children, that a poor performance of a child leads to stressed parents, which could lead to higher divorce rates. So this is one potential explanation. Yeah, so reverse causality. So instead of the divorce causing bad test results, it could be that the bad test results actually caused the divorce in the first place because the parents are feeling stressed. Another issue could be given by a third variable, which might impact both the divorce rate and the test result of the child. Okay, so another issue, third variable, affecting both test performance and divorce rate or divorce rates. So this is another issue. So what could be an explanation for this? So consider that the family is living in a kind of in a very bad place. Okay, so a place which is full with criminality. So full with criminals. So you have burglars there. I don't know. You have shootings every other week, and so on. And this can cause stress to the parents and to them fighting, which could yield a higher divorce rate or a higher likelihood for divorce to happen. And at the same time, it could impact the child's mental health such that the test results of the child will be lower or low compared to a family or a situation where a family would live in a place which is basically better. Yeah, so you have a better neighborhood. So one example, for instance, for instance, bad neighborhood. So for instance, bad neighborhood um, can impact mental health of all family members. Let us put it like this. So all family members, such that the parents fight and this causes high divorce rate. And the child the child performs and child performs bad in tests. Okay, so basically you have a third variable, which is then a measure for a good or a bad neighborhood. And this is actually affecting both test performance and divorce rates. So the only reason why you're seeing that the child has bad performance and the parents are having a higher likelihood to get divorced is because they're in a bad neighborhood. And actually, test performance and divorce rates have nothing to do with each other. They're independent, conditional on knowing that there is a measure for neighborhood. Okay, so this is one aspect, and the other thing was, reverse causality, in that we are not sure whether, what is cause, like what is the cause, and what is kind of the, which variable is causing the other one to change? Yeah, so we are not sure about this. This would be the answer for the first question. So the researcher should actually try, so when doing empirical analysis, the researcher should be able to kind of exclude those kind of explanation possibilities in order to be sure that he can make a valid statement with respect to the relationship between divorce rates and test performance. Okay, so question number two. You're hired by the government to evaluate the impact of a policy change that affects one group of individuals but not another. Suppose that before the policy change, members of a group affected by the policy averaged $17,000 in earnings, and members of a group unaffected by the policy averaged $16,400. After the policy change, members of the affected group averaged $18,200 in earnings, while members of the unaffected group averaged $17,700 in earnings. Now, question A is, how can you estimate the impact of the policy change? What is the name for this type of estimation? Okay, so this is exercise 2A. So the name of this approach is the so-called difference in difference approach. So name of the approach difference in differences. So what we are basically doing is that we will compare the difference between the difference of the affected group between the time dimension, so the 2 time points, and the other group. So the first difference is with respect to the groups themselves, so with respect to time, and the second difference is then comparing this time difference of the different groups with each others. Okay, so basically the question here is which kind of, or how much of the difference can be attributed to the policy change. So what we then do is that, first we consider the treatment group, so the treatment group difference. So what we do is we compare the differences in earnings for the treatment group after and before the policy change. So after the policy change, the treatment group had $18,200, and after the policy change, before the policy change, it had $17,000. So this will give us a difference of $1,200. The second group is the control group difference. Control group difference. And here we make the same comparison, but with respect to the control group. So after the policy change, the the control group had $17,700. Before it had 16,400, and this is equal to 1,300. And what you can then do is, okay, so the first thing that you naively could do is you could have a look on the change in the treatment of the like in a change in the earnings of the treatment group, and you see it's $1,200, and you could think that this policy had an impact on a treatment group which was equal to 1,200. But then if you consider that the control group also had a difference, this is the power of this difference in difference approach, because it assumes that apart from the difference in treatment, so that one is a treatment and control group, the two groups are on average the same. This means that whatever happens in the treatment group apart from the policy change also happens for the control group, and therefore what we need to compare is the $1,200 change with the $1,300 change, and that's the difference in difference approach basically. So what we then estimate is that, so the estimate of the effect is then 1,200 minus 1,300, which is then equal to minus $100. Therefore, we conclude or we estimate the impact of the policy to lower earnings by $100. Okay, so this is an estimation that we can derive from this difference in difference approach. But there is one issue, like even though this is a nice approach, there is also an issue with this, which brings us to question number B. What are the assumptions that you have to make for this to be a valid estimate of the impact of the policy change? And this is the so-called, so this is then exercise B. So this is the so-called parallel trends assumption. So parallel trends, which basically says that if there wouldn't have been the policy change, the developments of earnings within the two groups would have been the same. Okay, so like the trend in earnings without the policy would have been the same. Because if this wouldn't have been the case, then you cannot like know whether the change in this difference, so the difference approach, uh, is really due to the policy, like the difference that you get, this minus $100, is really due to the policy or because of some trend which would have happened anyways, independent of the policy. Okay, so um, if violated, so if violated, one cannot know whether difference between groups would have occurred anyways. Okay, so you need this parallel trend assumption. If you do not have this assumption, you cannot say whether the diff approach really gives you an unbiased estimate. And this finishes sub exercise B.